Hello students, welcome to my channel IS1 Academy. Today we will be doing Electrostatics part 3. The first question: two small conducting spheres of equal radius have charges plus 10 microcoulomb and minus 20 microcoulomb respectively, and placed at a distance r from each other experience force F1. If they are brought in contact and separated to the same distance, they experience force F2. The ratio of F1 to F2 is. So what we are given is, we are given two spheres of equal radii and the distance of separation between them is r, and one we have charge is plus 10 microcoulomb and other is minus 20 microcoulomb. So we have the force is in that case F1. Now what we do, we combine them, we bring them in contact. Now when we bring them in contact, what happens, the charges flow, okay, and the equilibrium is established. So what happens, equal charges will be there on both the spheres when they come in contact. Now what is the amount of charge? It is given by the formula, that is plus 10 microcoulomb plus minus 20 microcoulomb upon 2. So this is the formula for getting the charges on each sphere. So 10 minus 20 is minus 10 microcoulomb divided by 2. This comes out to be minus 5 microcoulomb. So when the two spheres, they are brought in contact with each other, each sphere will have a charge of minus 5 coulomb on its surface. So when they are separated again by the same distance, so now what the charge we have is minus 5 microcoulomb here and minus 5 microcoulomb here. Now in this case the force is F2. The distance is same as given in the previous case. Now what we have to find, we have to find the ratio of F1 to F2. So first of all, what is F1? F1 is 1 upon 4 pi epsilon 0. Q1 is minus 10 microcoulomb. We are just ignoring the negative sign. Q1 Q2 upon r square. And what is F2? So F2, I will write it here, equal to will come here. So F2 is actually 1 upon 4 pi epsilon 0 5 microcoulomb into 5 microcoulomb upon r square. So now we have to solve this. So many things get cancelled out. So what we are left is F1 upon F2. Now 10 to that, this is 200. It is 5 by the 25, and rest all the things they get cancelled out. So this is actually 8. So the answer 8 means 8 upon 1. So what the answer we have is F1 to F2 is 8:1. So this is the ratio. So here the answer is B, 8:1. Next is question number 2. One metallic sphere A is given positive charge, whereas another identical metallic sphere B of same mass as of A is given equal amount of negative charge. Then mass of A and B remain same, mass of A increases, mass of B decreases, and mass of B increases. These are the four options. So we are given a metallic sphere. So this is, let us this take this as A. Now in order for us to deposit some positive charge, we need to remove electrons. Okay, we are not adding any positive charge. In order to make any sphere positively charged, we need to remove electrons. So what we do in this case, for the case of A, we remove electrons. So we remove, in this case we remove electrons, so because of which this becomes positive charge. So here A has some positive charge. Now we have B. Now in order to deposit negative charge, we add electrons. so this becomes negatively charged. Now in both the cases, in case of A, we have removed electrons, we have not added any positive charge. So in case of A, there are less number of electrons, because of which it becomes positive. In case of B, it has more number of electrons, therefore it has become negative. So in this case, because electron has a mass, so in case of B there are more electrons as compared to A, so mass of B increases. This is the answer. Next is question number 3. Electric charges of 1 microcoulomb, minus 1 microcoulomb and 2 microcoulomb are placed in air at the corners A, B and C respectively of an equilateral triangle ABC having length of each side 10 centimeter. The resultant force on the charge C is, so we have 3 charges at the 3 corners of the equilateral triangle. So let this the first charge A, and here we have another charge B, and there is another charge C here. So we can just draw a line between them. So this is the line, the second one, the third one. So we can assume this is A. Here we have 1 microcoulomb charge. Here we have B, minus 1 microcoulomb, and here we have C, 2 microcoulomb charge. Okay. So let the force between A and C be F1. So this is the force between A and C. And let F2 be the force between B and C. So now we individually calculate F1 and F2. So F1 is 1 upon 4 pi epsilon 0 Q1 Q2. So Q1 is 1 microcoulomb. So 1 to 10 is to minus 6 into, this is 2. So 2 into 10 is to minus 6 upon, distance is between them is 10 centimeters. So we need to convert to meters, so 10 is to minus 2 the whole square. Now we need to calculate this. Now 1 upon 4 pi epsilon 0 is a constant and the value is 9 into 10 is to 9. So here 2 ones are 2 into 10 is to minus 12 upon, so this is 10 is to minus 1 raised to square, so 10 is to minus 2. So 9 2s are 18 into 10 raised to minus 12 plus 9, and this goes up, it also becomes plus 2 newtons. So we do the calculation, we have here 10 raised to minus 1 and this is 18, so it becomes 1.8 newton. So this is for F1. Now we do the calculation for F2. Now F2 is what we have is again the same thing we will get, because in case of B and C only the difference is B is minus 1 microcoulomb. So here, and C is again 2. So almost same calculation, only the difference is we get this as minus 1.8 newton. So this shows this is attractive force, this is repulsive force. Now no need to do calculation for this, we can directly add this. Okay, now we come to the diagram here. We in this case what we see, A and C both are of the same both are having the same sign, so there is a force of repulsion. So because of repulsion, the force acting on on C, F1 is will be going out, and here B and C, because one is negative, one is positive, so there is a force of attraction. So this is how the force will act. Now this vector I am drawing it again here. So we have this diagram. So this is F1, this is F2. So the resultant is this one, this is F. Now here this angle, so this is sum of these two angles. So because these were 60, so this becomes 1, this angle becomes 120, and subsequently this becomes 60 degree. Now this F, okay, is sum of the components of this F1 and F2. Now F2, it has two components. Okay, one component is F cos theta, which is acting along this axis, and F1 is also having two components, one component along this which is called as F cos theta, F1 cos theta. Okay, so the component of F1, F cos theta, and the component of F2, F2 cos theta, they make up this F. Okay, because I don't have time to explain this using the vector theory. So these are the two forces. So now we calculate the magnitude, the total force. Now this F is F1 cos theta plus F2 cos theta. Now F1 is 1.8 and theta is 60 degree. Okay, this is 60 degree, and again F2 is also 1.8 and theta is again cos 60. Now cos 60 is half, so 1.8 into half plus 1.8 into half, so this comes out to be 0.9 plus 0.9, so it is 1.8. So answer F is 1.8. So let us see in the option, we have 1.8, so here we see B is the correct answer for this. Next is question number 4. Charge on alpha particle S. Now alpha particle is actually the helium nuclei, and the atomic number of helium is 2. So it means in the nucleus of helium there are 2 protons and 2 neutrons. So we are only talking about the nucleus, not the entire atom. Helium atom as a whole with electrons, protons, neutrons is electrically neutral. So but we are talking here about only helium nuclei. So it has 2 protons and 2 neutrons. Neutrons, they are chargeless, and proton carries a positive charge. So there are 2 positive charges, and the charge, the value of charge is 1.6 into 10 raised to minus 19 coulomb, because there are 2 charges. So we have 2q, 2 multiplied by q, so this is 1.6 into, so 2 into 1.6 into 10 raised to minus 19, so this comes out to be 3.2 into 10 raised to minus 19 coulomb. So C is the answer in this case. Next is question number 5. Two charges are at a distance d apart. If a copper plate, which is a conducting medium, of thickness d by 2 is placed between them, the effective force will be. Now let us assume these are the two charges. Sorry, this is one charge, a point charge. This is another point charge. They are separated by distance d. So this is the distance between them. Now we introduce a copper plate between them, such that the thickness is d by 2. So here d by 2. So this is the thickness. This is the plate. Now what is the force between them now? So suppose initially the force was F. Now we are introducing this medium. Now force is given by 1 upon 4 pi epsilon q1 q2 upon r square, the distance, or here in this case it is d square. Now I have written here epsilon, not epsilon 0, because we are introducing some medium. If there is no medium, air or vacuum is there, we write epsilon 0. Now epsilon is actually epsilon 0 k. For air and vacuum, k is 1, so we generally write epsilon 0 directly. Now in this case, for copper is a metal and a conducting medium. For that case, k is infinity. Okay, for air k is 1, but for metals and all the conducting mediums, k is infinity. So what we get here is F is equal to, so this epsilon becomes epsilon 0 k. So we have 4 pi epsilon 0 k q1 q2 upon d square. Okay, but k is infinity, so we have 1 upon infinity, which is equal to 0. So because here k is infinity, so everything will become 1 upon infinity. So F is equal to 1 upon infinity, which is 0. So the answer in this case is C. Next is question number 6. Two charges placed in air repel each other by a force of 10 raised to minus 4 newtons. When oil is introduced between the charges, the force becomes 2.5 10 raised to minus 5 newtons. The dielectric constant of oil is. So what data we are given? Let us take force between the two charges when in their air is Fa. Now we apply Coulomb's law. We have 1 upon 4 pi epsilon 0 and Ka, where Ka is the dielectric constant of air, which is actually 1. Therefore in general we always write 1 upon 4 pi epsilon 0, but because here oil is also there, so we are writing this Q1 Q2 upon R square. But because Ka is 1, so this equation becomes 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. But this is 10 to minus 4. Then for oil we write FO, which is 1 upon 4 pi epsilon 0 KO. KO is the dielectric constant of oil, Q1 Q2 upon R square. So this remains as it is, and this is given as 2.5 into 10 raised to minus 5. Now that this is 1, this is equation 2. So if we divide 1 by 2, what we get, I will write it here. So this equation, this one, so in 1 we have 1 upon 4 pi epsilon 0 Q1 Q2 upon R square, and for oil we have 1 upon 4 pi epsilon 0 K0 Q1 Q2 upon R square. This is 10 to minus 4, and this is 2.5 into 10 to minus 5. On the left hand side there are many things which are common in the numerator and denominator. They will get cancelled out, and we are left with 1 upon K0. Here 10 to 5 will go up, it becomes 10 to minus 4 plus 5 is 10 raised to plus 1, and this is divided by 2.5. So here at the left hand side we have K0, 10 divided by 2.5 is 4. So the answer in this case is 4 is the answer for this case, this one. Next is question number 7. When a glass rod is rubbed with silk, what happens? So when a glass rod is rubbed with silk, glass loses electrons and silk, it gains the electron. So what we see is glass gives electrons to silk. So glass becomes positively charged. Okay. Glass, it gives electrons to silk. So this becomes positively charged, this becomes negatively charged. Next is question number 8, the last for this session. Dielectric constant for metal is 0, infinite, 1, greater than 1. Now the dielectric constant, the least value of K is for air or vacuum, which is equal to 1, and as the medium becomes more denser, the value of K increases. So for metal they are very dense, so for that purpose K is infinity. For metals K is infinite. The least value of dielectric constant is for air and vacuum, which is K equal to 1, and for all the other medium it is always greater than 1, and for metals it is infinite. So the answer is B, infinite. So that's all for today's session. Thanks for watching.